Hey, good morning, good afternoon, good whatever time you're actually watching this. Um, I guess, in my experience as a Tiger hack, like all your time just runs together. But thank you for joining me. I wanted to talk about something called gRPC. I believe it's the future of networking. Um, it's something that I use pretty much every day, using networking to talk back from services to service. But it's also particularly useful if you ever need to build like a chat room for a class. I'm looking at you networks, or if you're ever just wanting to learn about like a new technology that like the big tech names are using. Um, I'm David Emily. I recently graduated from University of Missouri from the computer science department. It was great. Had a lot of fun. I stayed in the area. I worked for Veterans United. A great company to work for if you're looking at places to apply or try out. Definitely recommend Veterans United Home Loans. It's been terrific. I interned there my last semester, so I was working at school and also coding. Huge learning opportunity. It made going to school so much easier because I had this bigger idea of how everything tied together and how it was used. But that's not why you're here. You're here to learn about gRPC and how you can use it in either your application or in your homework. So let's dive into it. To start off, gRPC stands for Google Remote Procedure Call. If you Google this, if you look this up online, the G is typically lowercase. This procedure is actually open source, so Google doesn't own it. And I don't even think they maintain it anymore. I think it's maintained by the free open source group. But it uses protocol buffers. So it's kind of a big word. I hope you don't get thrown off too much by that. I think once we actually start seeing it in code, it'll make a lot more sense. But basically, that's a contract. So both the server and the client, which is consuming that, both know of the same contract, and they use that to validate to each other. And they validate to each other over HTTP2, which for those that don't know has massive benefits, both performance and security over HTTP1, and it's kind of how everything is moving. gRPC also adds features such as bidirectional streaming, which is super cool if you're using big applications and you don't want to make like a separate network call, or if you have like a continuation of messages coming through, you don't want to make a separate network call from all of those. So you just create a gRPC channel and you send the messages back and forth. So that's a lot of words, and I hope, or a lot of acronyms and a lot of words that you may not have used yet. Please don't let that overwhelm you. It's basically the same as typically how we communicate over networks now, just different words, and they have amazing tools to extract that out. So stick with us. But this problem all came from, in the beginning, services were these massive monoliths. So you had this one machine that would do everything for you. So you just sent it a request, and it would just chug away at everything it needed to do. And when it was done, it'd send you back the request, or the response. So kind of like how in 1050, when you're first learning how to program, you just shove everything into main. So the main function, you just put everything in there, all of the logic, everything. And then as you kind of, work in code, you realize that there's specific functionality or features that you could pull out into functions. And then you could just reuse that code in main to call that function instead. So that's kind of how the way monoliths are. Monoliths are just everything in code. There's no network calls. Everything's handled inside that service. And through using these, we found out that it's hard to update code or to add new features. So we switched to this design thing called microservices. And microservices are the idea we kind of talked about with functions is instead of having everything in main, we now also put new features and stuff into these functions that can be reused. Well, just like that, instead of everything being in the same server box now, we break out specific features of those and we call microservices. So these are separate servers or services that the main service communicates with, and we can chain these together. We can use them however we want. That's the benefit of them being apart, is they do one specific thing, and anybody that needs that specific thing done can call them. So it's great as a developer because my code base is smaller. If I want to do a new feature, I only have to worry about deploying the code base microservice instead of deploying all of this new code in the main stack and worrying about breaking stuff. So super, super useful to work with. The bad thing is, if these aren't on the same server, that we're now making these network calls to these different microservices. So what used to just be a single server processing everything inside of it is now processing some of it, calling over the network for this server to process some of it, sending a response back, calling another server to process it. And it's a lot of network calls, which adds a lot of time and complexity, because now you're sending a request, you're parsing the request that you sent, you're doing whatever logic, you're sending it back, and then the other service has to parse that. And if you change something on one side and not the other side, you can't communicate anymore. So these microservices kind of opened up this need to streamline what's going over the network calls to the different servers. And typically how we do that, at least how I typically do that on the job, or when I did this in school, is we use these HTTP APIs and we communicate it over JSON. So what this means is, we type up in this JSON, this JavaScript notation, word for word in English, human readable things, what I wanted. So I'd put name, my name, etc. And then I would just send that over HTTP1 to the other server, which would then parse that and do what they wanted with that information. So kind of here we have that written down. There is streaming from the client side to the server. Any HTTP is valid, so it's very easy to just send this request to anywhere with valid HTTP. I can actually see the request in the console log or on the screen, which makes debugging really easy. And there's some movements towards standardizing this. So we have OpenAPI. So I'm actually going to kind of showcase a thing of this I use at work. So this is an example of a typical JSON blob that you may be sending over HTTP. So I work for a mortgage company, so a lot of this is more mortgage centered. But basically, we have here, I would need, if I wanted to use the service, I have to build a JSON object to do all of this. So every one of these fields I need to fill out. And if any of these fields are misspelled, the contract's broken. I'm not getting any value from that field. Or if I change one of these. And the fact that it's human readable doesn't do any benefits to the computer, because the computer doesn't have any problems reading language that it's prepared for. So this is where the gRPC comes in. So this here is that instead of just having this JSON blob, there's something called the .proto. And I'll showcase this later in code. But basically, this is a hard-coded contract that the computer can then encrypt and make smaller. So instead of having JSON name, first name, I'll put that into the proto. And then the computer knows that anything in that slot is what it needs to read. So this means the computer can shrink down the sizes to make it a lot easier to send across the wire. And this also means that I'm now hard set to that proto. I'm hard set to that contract that we made with each other. So I instantly know if I break that contract. The code will let me know that, hey, I can't send this out because this is a bad contract. They don't know how to read it. I don't know how to read it. So it kind of enforces your servers or services being able to talk to each other. This goes for HTTP2, which I have a slide coming up, but it's a massive benefit. Speed is better, security is better. HTTP2 is really kind of the new way in web traffic, and we're just waiting for everything to catch up. The payload, once again, is a protobuf. It's binary as opposed to human readable. So it's a lot smaller. Another benefit is there's strict specifications on how to use a protobuffer, which sounds like it would be harder to use because you have to match the specifications. But I think actually using it, and we have a slide coming up, will kind of help you. I think it's easier to learn because you only have to learn the specification. You don't have to worry about how like someone does one thing or another service does another thing. And then bidirectional streaming and TLS, lots of benefits to gRPC. So here's what I was talking about. The performance that comes along with this is this protobuf. Because everything is binary, the computer isn't sending human readable language, but rather language it understands. So I actually have here a website where it shows the difference. This picture over here is loaded using normal HTTP1, and this over here is loaded using HTTP2. So that time it was double the speed, and here it's even more than half the speed it took to load this over HTTP1 as it does to load it over HTTP2. So here we are, we're already gaining the speed of using HTTP2, and then this is also a binary request, so it processes much faster than this. So massive performance gains there, and then also a pop-up going on my phone or on my computer. People are talking to me. And then also it eliminates this thing called head-of-line blocking, which is when you're sending a call to a service, it can sometimes lose the order, the track that it's going in. So it's very important that typically you have some way to make sure your messages are in order, and gRPC eliminates this because it's guaranteeing that all your messages come in order. And then streaming is kind of the way everything's going, and we do that through, there's lots of services out there that instead of just posting an information or you asking for an information and it sending a response, it's just this constant back and forth. So the speeds there increases a lot of, it gives you a lot of abilities that you didn't have earlier. So you can instead subscribe to this server service, and it's constantly pushing information as opposed to a request out and a request in. And then here we're talking about specifications. And I think that's one really cool thing about gRPC is there's a set way to do something. So once you learn how to do it in that set way, you never have to worry about it again. Where if I'm generating a JSON blob, I can make that any way I want. I can use uppercase, lowercase, I can use different ways to communicate it out. I can use weird modeling. But here in this Proto Developers Google, they tell you exactly how to use it. So if we go over here, and I wanted to learn how to use it using C#, this tells me exactly how to use it. And when I build it this way, I can communicate with any other gRPC service. So I can have a Python backend using this, and I can have a C# service calling this, and they will match up because that's just gRPC and how it works. So this is really cool. If you're interested in gRPC, Google has a lot of documentation on the proper way to build stuff and use it, and it makes it a lot easier. So please don't get overwhelmed by the names. Definitely give this a try. I think it'll be huge. And finally, I kind of wanted to show it to build a chat room. So I remember one of my homework assignments in networking, I had to build a chat room, and it was really hard. And I wrote a lot of lines of code. I think I wrote 200 lines of code to get this chat room working. And here I wanted to use it using gRPC, and I think it comes out to be like 40 lines of code on the server and 30 lines of code on the client. So this operates over command line. I already built the server because I figured you all wouldn't want to see me code in JavaScript. So it's on my GitHub, and I welcome anyone, if you're interested in this project, to please use it, test it out, let me know what you think. So here I'm going to, oh shoot, I actually already have this. So this project is cloned down, so I can actually go into here. And I think it's already installed, I'm sorry. So I wrote this program using JavaScript. And I use npm as the package installer. So when you pull down this code, you'll have to run npm install. And I told npm to track gRPC, so it's actually going to pull down that information in it. And then here's the code base. I mentioned using a proto and how that's a contract. So this is all I need to build this proto between the services is user and text. So this is going to be the message you send. So I actually have that stored if I show everything. That's up here in this protos library, or protos folder, because I have this chat.proto, which is what they're expecting to use. And then here, I pasted the code here on the server. I think it's kind of hard to read this way, but if you go over here, you can see the code here. Basically, here's how we consume gRPC, is we let it know what it is and what a proto loader is, how it can read the binary information. We build the proto here of ways to communicate, and then we use it down here. So this is the server. A lot of this is just server talk needed back and forth. And then here on the client, we tell the same thing. We pull in gRPC. We load up the proto loader how we expect. It uses the proto that we built with the username and name. It connects to the server. And then here it uses that proto to send back and forth. So this message is the proto contract that we generated. So by me installing this, I'm currently in the project. I can just spin up the server using Node or npm. Let me check. I took notes. Node. Okay. So I'll go here and I'll go Node server. And then this is running the server.js file. So it's going to hang over here. It's saying what it's running on. And then I'm going to open up a few more PowerShell windows that I'm going to use as clients. So it asks me for my name. I'm going to call this one David1. And then I'm going to open up another one. I'll call this one David2. Cool. So we can see here on the server it's repeating that someone else joined in. And then by using this, I can just simply say like, hello David2. This is super cool. And I see that over here in David2's window. So I'm going to respond, yeah, this message is being sent in gRPC. And I get that back. So these files, of course, aren't that big, but we gain a lot of speed by using this gRPC proto. And I'm able to talk back and forth amongst these. So super easy chat room. We built it in maybe 60 lines of code between them. So if you ever need to use communicating between two different clients or something, I would definitely recommend using, or at least attempting to use gRPC. To end it all up, just to rehash, I'm David Emily, Mizzou grad developer, Veterans United. I hope you feel free to reach out if you're interested in talking about what it's like being a developer, or if you have any questions on gRPC, or if you have any questions about Veterans United. My GitHub is linked. Feel free to pull down the gRPC if you'd like a closer look. Feel free to, I guess just follow me. I'll follow you back. And last but not least, I hope you join me at Veterans United because it's a great place to work. Thank you for your time, and good luck hacking.